This is a tutorial on how to use Knot.x Fragments together with Knot.x Chrome Extension in order to easily implement third-party integrations. What you see on screen is an HTML page that right now is not processed by Knot.x, as you can see by the raw templating engine markup. And what I'm going to show you is how to use Knot.x in order to populate this with data from mocked services. And this example is to demonstrate how powerful Knot.x mechanisms are. Let's take a look at the HTML markup of this page. This is the page. As you can see, it's mostly just typical HTML. However, it has two special parts, Knot.x snippet over here and another Knot.x snippet over here. Those are so-called fragments. The first fragment contains user details section and handlebars markup, and the second one contains payment providers and offers sections and pebble markup. The way it works is that Knot.x fragments will take those two fragments and process them independently from each other, then put the output back into the HTML page in order to be shown to the user. This is why it's not a problem for two different templating engines to be used on the same HTML page, because they are in different fragments, so they will be processed independently. Now, right now, as you could see, they are not processed because those fragments aren't configured. So this is what we will do now. The first fragment defines data Knot.x task as user task, and this is the name of the task that this fragment will be processed by. I have a special file prepared in which I can write tasks configurations. So let's go into it. And let's define user task. And I'm going to write action fetch user info. And what it is, it's a graph. I'm defining the root node of the graph that defines data flow. So right now I have it defined so that the first thing that will be done during processing of the fragment is to execute the fetch user info action. So now let's define this action. I again have a file prepared for defining actions. Note that task defines the structure, the data flow, while actions define what should be done at any given step. So let's define the fetch user info action, and I'm going to write factory HTTP. Every action is produced by a factory, in this case an HTTP factory, and this factory just produces actions that call some services over HTTP and retrieve data. So I have to define what service should it call. So I'm going to write config endpoint options, and I have to define path, so an endpoint, and I have mocks prepared. The user endpoint provides JSON data about a sample user. Another thing I need to define is domain, and in this case it's web API. I have this example running on a Docker service that is configured in such a way that the mocks are available under the web API domain. If it weren't on Docker, it would probably be localhost. The last thing I'll define is port 8080. If I left it at that, I would have a RESTful API that calls the user service and retrieves its data. But this is not what I want. I want to render a page with this data. So I have to have a way to define that when the user data are retrieved, I want to trigger a handlebars engine to process the markup. So I have to go back to the tasks file, and I'll define a transition. So on transitions, on transitions success. Transitions are basically graph edges, and the success transition is triggered when the node succeeds. So now I'm defining the second node, which will be executed after the node with fetch user info succeeds. I have to define what the second node will do, so action, and I'll define it as TEHBS. It stands for Templating Engine Handlebars. Now the only thing left to do is to actually define what TEHBS action is supposed to do. So let's go back to the actions file and define TEHBS. I have to define a factory, and I'll define it as not. Now, you could imagine that it should be something like handlebars, and it actually is under the hood. However, this action is defined on the vertex event bus, and in order to provide more scalability, and the not factory allows us to reference actions defined on the event bus. So the only thing I need to configure it here is the address on which the action is registered on the event bus. So config address, and in this case it's Knot.x not TE handlebars. This is all I need to do, and it will become clear in a moment. Let's see how the page looks like now. A quick side note, I had a typo in the address of the handlebars action, so I fixed it, and now you can see that the user details section is actually filled with data, and that's because this time the first fragment was processed by Knot.x. Here's when the Knot.x Chrome extension comes in. I have it installed already, so it's available in the inspector. So let's see how it looks. This is the main screen of the extension, and the most important thing here is the list of fragments. Now you can see there are two fragments. That's because we have two fragments defined in the HTML, but the second one has a gray box next to it. That means that it wasn't processed, so I will ignore it for now. The first one, which is the user details, succeeded. It has a green box next to it. We can see that it took 25 milliseconds to execute. If I click this arrow, then I can see top level HTML tags that this fragment contains. So this is user details. Okay, I'll hide it now, and I'll go into the most interesting part of the extension, so into the details of the first fragment. Here's how it looks. This is the structure of the graph that we defined. This is the exactly same thing that was in the tasks file. We have the first node, which calls fetch user info action, and then on the success transition, we have the second node, which calls the TEHBS action, which actually renders the page. Everything is green, so everything ended with a success. I can go to the details of the first node, and now I can go. I have here a lot of debug information, and for example, I can go into the response invocations, and then see logs, and here I have logs of the execution of the HTTP action, so I can see exactly what the request was, what the response was, and what the response body was. So in this case, we had a JSON with some sample user data in it. The way this extension works is, as you can see, in the address bar, there's a debug query parameter set to true, and this tells Knot.x to put information about execution of fragments into the HTML markup. It does it in such a way that it doesn't influence or disturb the page in any way, but the Knot.x Chrome extension can read it and display to us in this form. Now, this is a very simple example, so now let's head over to something more complicated, the second fragment. This is the HTML of the second fragment. As you can see, it defines its data Knot.x task as payments task, So this is the name of the task that this fragment will be processed by. Let's go to the tasks file and let's define payments task. And what this task is do, okay, I'll go back to the HTML page and I'll explain it a bit more. We have the payment providers section and offers section. And for the sake of this example, I assume that the payment providers come from one service and offers independently come from another service. But they both require the user information. So they are both user specific. We have to retrieve the user information first, but then the offer service and the payment provider service are independent. So going back to the tasks file, we have defined the payments task, and what it needs to do, it's, as I said, it needs to retrieve the user information. So I'll write action, and we can reuse the action that we already have, which is fetch user info. And now, when we are done with retrieving the user information, we need another node on success, and this node will need to retrieve information about providers. So let's define action and fetch payment providers. Now, when this succeeds, we need another node. So on transitions success, now the third node needs to retrieve information about offers. So we'll define action fetch offers. And finally, in the last node, we need to actually render the page. If it were handlebars, we could reuse the THBS action we already have, but as I mentioned earlier, this is actually Pebble templating engine, so we will need to define a separate action for this. So on transition success, so when the fetch offers succeeds, we'll call the action, let's call it TE Pebble. Now we have already defined the fetch user info. We need to define fetch payment providers, fetch offers, and TE Pebble action. Let's go to the actions file and let's define fetch payment providers, so action that will retrieve data about payment providers, and this is again an HTTP action. So let's configure endpoint options, and in this case those are still mocks. The endpoint is payments, path payments, domain is again web API, and port is 8080. The language that I'm writing this configuration is called Hokon, and it's specifically designed for writing configurations. There are ways to avoid repeating ourselves. Normally, I probably wouldn't need to write basically the same thing again and again, but for the sake of this tutorial, I'll just copy and paste HTTP actions from now on. Oh, I've just noticed that I have HTTP. Let's fix this quickly. Okay, so this is the fetch payment providers action. The fetch offers action will be almost identical. So as I mentioned, I'll copy this and just change the endpoint to offers. And finally, we need to define the Pebble templating engine action. We call it TE Pebble, and it's also just like the handlebars action defined on the event bus. So let's define factory as not and configure the address, this time as Knot.x .ce Pebble. This is all we need to do. Again, those are the actions that will be executed, and in this file we have the structure of data flow. It will become clear in a second when we can view it in the Chrome extension. Let's see the page now. As you can see, the payment providers section and the offers section is filled with data this time, That's because we have a configuration for the second fragment. Let's take a look at how it looks in the Chrome extension. There it is. We can see now that the second fragment also succeeded. Let's go into details. And here's how it looks. It's pretty straightforward. We fetch user information. After success, we fetch payment providers information. After success, we fetch offers information. And then after success, we render it with templating engine Pebble. Again, we can go into the details of nodes and see the debug information that we need. Let's close this now. Now, this works, but this isn't ideal because, as I mentioned earlier, the fetch payment providers and fetch offers are independent from each other. So it would be better if they could execute in parallel, because right now there's no need for fetch offers to wait for fetch payment providers to succeed. Also, not to mention what would happen if fetch payment providers failed, because, for example, the third-party service went down, then the fetch offers wouldn't execute, but it probably could. Maybe we can't show the payment provider's information to the user, but we can at least show him the offers. So let's implement the parallel approach now. Here is our payments task configuration, and here's when the two types of nodes come in. Everything that you've seen up to this point were so-called single nodes. Single nodes just have an action, and when they are triggered, they execute this action. There's also the second type of node. It's called composite node. And what it does, it has a list of other nodes. It executes all those nodes in parallel, waits for all of them to succeed, and if all of them ended with success, then the composite as a whole ends with success. It's pretty simple to implement. Let's just comment it for now, and let's define on transitions success again. And this time we have to have a composite node. So I will define an array called actions, and this array will take two objects, two nodes that it will execute in parallel. So the first node that it will execute the action fetch payment providers, and the second node will execute the action fetch offers. Note that I don't have to change anything in the actions file because I'm not changing how the data is retrieved. I am only changing the structure of the graph, structure of the data flow. So now that I have the composite node, I want to have a transition to the templating engine renderer only after both of those actions succeed. So I have to define the transition for the whole composite. So right over here, I define on transitions success, and I'll call templating engine Pebble action. And this is actually all we need to do. I can delete this commented code. All we need to do. Let's see the page. It looks the same because it still retrieves the same data and renders in the same way, but let's take a look at how it looks in the Chrome extension. Let's go to the details of the second fragment, and now we can see something like this. I'll explain it. Here we have the fetch user info node, and after it succeeds, we have a composite node. The white circle represents the beginning of the composite node, and then at the bottom, the second circle, which in this case is green, represents the end of the composite. So at the beginning of the composite, we execute the fetch payment providers action and fetch offers action in parallel. And then, because they both succeeded, we the composite as a whole ended with success, and that's why the second circle representing the end of the composite is green. And then after the composite ended as a whole, we have a success transition to T-pebble action. So that's a little bit more efficient. It's a better design of the graph. Let's view the second view of the Chrome extension, which is the performance view. Here it is. Let's go into this. I'll close this quickly. And here we can see how the nodes were executed in case of time. So we can see that first the fetch user info was executed, and after it succeeded, then the composite was executed. And only after the whole composite succeeded, the TE pebble action executed. And if I now open the composite, we can see that it has two subtasks because those nodes that are executed in parallel are called subtasks. First is fetch payment providers and second is fetch offers. And we can see that they actually were executed in parallel, and only after the longer one of them ended, the composite as a whole ended. Let's go back to the graph view. This is, as I mentioned, this is a lot better, but this is still pretty idealistic scenario because we don't handle any errors. Everything works instantly and everything succeeds. So let's now consider what would happen if let's say one service took a long time to respond. We can actually simulate it using the Knot.x. Let's go back to the code. Here in the actions file, I can swap the path of the fetch offers action to the endpoint called timeout. The timeout endpoint also gives us data about offers. However, it is configured so that it takes 3 seconds to execute. So this is just the way that I simulate that this service takes a long time to respond. Let's see how it looks like in the page. I'll refresh the page. As you can see, it takes a long time to load. It still works, but it takes a long time. Let's see the Chrome extension. And as you can see, the problem lies in the second problem because it took over 3 seconds to execute. Let's go into details and into the performance view. Here everything still succeeded, so let's go into the performance view. And here we can clearly see that the problem lies in the composite. If I hide this, you can see that the composites took a long time compared to the other nodes. And when I open the composite, I can see that specifically the fetch offers took such a long time. There are obviously there are ways to deal with it. For example, we can define a timeout. Let's go into the code. The most simple way to define the timeout would be to just configure it in the action. But there's a smarter way to do it that is available out of the box in Knot.x, and it's called circuit breaker pattern. Let's define a new action. I'll call it fetch offers CB for circuit breaker, and it will use factory CB again for circuit breaker. Now, what circuit breaker is basically a wrapper for other actions that takes care of failures. We will define the circuit breaker that will execute the fetch offers action inside of itself, and it will register its failures. And when it fails, for example, 3 times or 5 times or even just 1 times, then the next time the circuit breaker is called, it will not call the actual fetch offers action. It will just assume that something is wrong, it doesn't work, and it will just return failure straight away. And then maybe after some time, let's say 10 or 20 seconds, it will let the action execute again to see if it works now. So I have defined the action fetch of a circuit breaker. Factor is CB, stands for circuit breaker, and I have to define the doAction property as fetch offers. And this is the wrapper part that I talked about. This action will execute the fetch offers action inside of itself. And for the configuration of the circuit breaker, config circuit breaker options, and sample configuration could look like this. Max failures equals 3. So after 3 failures, the circuit breaker will assume that the action doesn't work. Timeout, which is the most important in our case, let's define it as 500 milliseconds. And reset timeout. Reset timeout is the time it takes for the circuit breaker to assume that maybe the action works now, so it will let it execute. Let's define it as 20 seconds. It doesn't matter for this example. What matters is the timeout. And now the other thing we need to do is to go to the tasks file, and this time we don't want to execute fetch offers directly. We want to execute the fetch offers circuit breaker action, and it will call fetch offers inside of itself. So let's take a look at how it looks now. The second fragment clearly failed because the payment providers and offer sections aren't even processed. So let's take a look at the Chrome extension. As we can see, indeed the second fragment failed, which is indicated by the red box next to it. Let's go into the details of the fragment, and there's quite a lot going on here. I'll move this node over here for readability, and I'll go through it node by node. First is the usual, the fetch user info. After success, the composite runs the fetch payment providers, and in parallel, fetch offer circuit breaker. Now, there are two transitions going from fetch offer circuit breaker, the dashed one and the solid one called fallback. The dashed one means that this is a transition that exists and potentially could be triggered, but in this case wasn't. So if fetch offers circuit breaker ended with success, then this transition would be triggered and success would be returned to the end of the composite. However, if in this case something went wrong and fetch offers circuit breaker triggered the fallback transitions. Let's see what went wrong. Go into the details of the circuit breaker. Go into response, invocation, logs. And here we can clearly see the reason it failed: error, exception, operation, timeout. So it timed out, as we expected. Now, because it timed out, it returned the fallback transition. It's blue because it's a custom transition. The transitions are just strings. Success and error are standard transitions. That's why they are represented by green and red. But anything other than that, for example, fallback, is a custom transition which is shown in blue in the Chrome extension. Now we have this yellow node with an exclamation point inside, and we didn't define it in the configuration, and actually this node does not exist during the fragments processing in backend. This is just the extension way of pointing to our attention that there probably should be a node there. We have a fallback transition, but we have no node that is able to handle it because we didn't define what should happen on fallback transition. So we have a missing node. This is what it is. It's a missing node. And because we don't have anything that can handle the fallback transition, the fallback status is actually returned to the end of the composite, and therefore, because not every subtask ended with success, one of them ended with fallback, the whole composite ended with error because the composite can only end in either success or error. And now again, we have a dashed transition. So the transition that could but weren't taken in this case, that would render the page using TE pebble, but the composite actually ended with error. And so there is an error transition pointing to another missing node because we didn't define what should happen if the composite failed. So this is how it looks now, and we'll fix it now. We have to define the missing node because right now the data is retrieved but can't be rendered. Let's go into the code. This is our configuration for the second fragment. So first thing we have to change is we have to define the error transition for the whole composite. So let's do it like this. And let's the brackets got messed up. I think this is okay, and remove the dot here. Okay. And so we still have only the success transition, and now we can add the second transition, which is an error. And we have to define what should happen if the composite fails. And actually, we still want to render the page with whatever data we were able to retrieve. So I will define it again as the tpebble action. So right now, really, no matter what happens in the composite, the page will render after all. And the second place, when we need to define a new transition because of the missing node, is the fetch of a circuit breaker. We have to define a fallback for it. So let's do it. I will define onTransitions property, but this time not for the whole composite. This is just for this one node, for this one subtask of the composite. And we need to define fallback transition because this is what the circuit breaker is using. And now we should define some action, say what should happen in case the fetch of a circuit breaker fails. So we couldn't retrieve the office data. We could probably fetch it from cache or from some other service or really anything else. But for the sake of the example, I'll just call the fetch office action, or actually I'll define fetch office fallback. So and now going to the sorry for that. And now going to the second file, I can define the fetch office fallback action, which in this case, for the sake of the example, it will just call the office endpoint. So I'll copy the HTTP action configuration and change it to office, so we don't have to wait 3 seconds because we assume that this is probably a cache or some other service that in this case works. So this is the only thing that we changed. We added one action which can retrieve offers data from, let's say, another source. And in this file, we have defined 2 new transitions to get rid of the missing nodes, so the fragment can actually succeed. Let's see the page now. As you can see, something weird happened. We have information about payment providers, but we have nothing in the office section. This is actually expected. I'll get to it in a moment. First, let's take a look at how the Chrome extension looks in this case. As you can see, the second fragment succeeded this time. It clearly was rendered, at least partially. Let's go into the details. I'll again move this for readability, and we can see that everything succeeds. This time fetch offers circuit breaker still returns fallback, but this time we have a node that can handle this fallback. This node ended with success, and so it returned the success to the end of the composite. And because all subtasks of the composite returned success, the composite as a whole is considered a success, even though there were some errors along the way. And it ended with success, so we could render the page using Pebble. So if everything is okay, then why we don't see any offers? Let's go into the details of the fetch offers fallback to make sure that it actually received the information. So response, invocations, logs, response body, and we can see that it indeed retrieved some offers data. So the problem is with the renderer. Now let's go into the HTML page. This is the second fragments markup. Let's see how it actually looks like. As I mentioned, this is Pebble, and in the case of offers, it gets the offers data from a key called fetch offers. The way it works is that every action by default saves retrieved data under its name. So if the data is retrieved by an action called fetch offers, then it is saved under the fetch offers key. But in this case, the action that actually retrieves the data is called fetch offers fallback. So this data is actually available under the fetch offers fallback key. There are a few ways to deal with it. One way would be to use another action called inline body that can just rewrite data from one key to another, so that no matter what action retrieve the offers data, it's always available under the same key, for example, under the key fetch offers. But for the sake of this example, I will just copy this loop, paste it back below, this time retrieve data from fetch offers fallback. So in the case everything goes okay with the circuit breaker, we have data under this key, so we render this loop, and in case something went wrong, we have data from the fetch offers fallback, and so we render the second loop. To make it clear, let's call it fallback offers. Fallback offer and fallback price. Let's see what will happen now. This time everything is rendered correctly. We still have payment providers and we have offers data, but as we can see, those are the fallback offers and fallback prices. The graph obviously looks the same way because we didn't change anything in there, we just changed the snippet markup in the HTML. So this is all I wanted to show in this tutorial. It's also available in text form on our website knot.x.io. The link is available in the description.